talked about if they were on the unit circle, but they weren't exact values. So like cos of 5 degrees. If I wanted the coordinate at cos of 5, I'd go cos of 5, sine of 5. So if I asked you for the coordinate at 5 degrees, you would literally go cos of 5 degrees, sine of 5 degrees. Now if I go cos, before I hit the cos button, I slap my hand and I say, what mode do I need to be in? What is this? Degree. So what mode do I need to be in? Degree. Boy. So I go to degree, change my mode to degree, and then I go cos of 5. Everyone should be trying this to see if they can get it in their calculator, because I'm really good at it. Stellar. So what mode do we need to be in when we go to press sine, cos, or tan, or second sine, second cos, second tan? We have to stop ourselves and say, what mode do I need to be in? Oh, it's degrees. So for 3 decimal places, what am I going to get? 0.996. And then sine of 5 degrees. 0.087. 0.087. Okay. I want you guys to try this one. I want the coordinate on the unit circle at 6 pi over 5. Coordinate on the unit circle at 6 pi over 5. So this time we would go cos 6 pi over 5. We don't have to convert it. Sine 6 pi over 5. But we just have to make sure we're in what? Radian mode. Because 6 pi over 5 is a radian measure, correct? So we go to mode, we go to radians, and we go cos 6 pi divided by 5. And I got negative 0.809. And then sine 6 pi divided by 5. I get negative 0.588. So mode matters, yeah. It's true. So if you went 6 times pi divided by 5, it would be 3.76999. So if you left it in degree mode, they would be looking for cos of 3.769 degrees, not 6 pi over 5. So you get different answers. That would work. Yeah. Okay. Cos 5 pi over 6. If it's over 2, 3, 4, or 6, it's on the unit circle. We agree? With radians, if it's over 2, 3, 4, or 6, it's on the unit circle. So go look for cos 5 pi over 6 and give me an answer. Sorry? I want this one. No, we're over here. I want cos of 5 pi over 6. So it's just negative square root 3 over 2. Why is it only one answer? Because it's the cos. And the cos is always the x. Calgary Stampede, correct? Now if I asked you, so we were always giving coordinates because I asked for the coordinate, but now we're going to go over ones where it's singular. So say I ask you for sine of 5 pi over 6. What's that going to be? 1 over 2, because it's the y at 5 pi over 6. So cos is always just the x. Sine is always just the y. Okay? So before I do tan of pi over 3, I'm going to not go there yet. Say I do sine of pi over 3. What's sine of pi over 3?
3 over 2.
And what's cos of pi over 3? Cos of pi over 3?
3 over...
No.
1.
1/2. So you can get answers really quickly for sine and cos off your unit circle. You did this last year in grade 11. You just did it with degrees instead of radians. Okay? So you can get answers really quickly off of it. So what if I do this, though? What if I go cos of 570 degrees? Minus 360, get its coterminal, right? Because its coterminal will land on the same arm. So if I just subtract 360 from that, I'm going to get 210. So actually, cos of 570 equals its coterminal, cos of 210. These are actually equivalent. If I subtracted another 360, I would get negative 150. Cos of negative 150, same thing. These are all going to give me the same answer because they're going to terminate on that same arm, same arm, same arm. Cos is the what? The x or the y? So what's the x at 210? Negative? Does it kind of make sense? Okay. We're practicing before we even get to them because we're going to keep practicing. Say I give you this. Ready? Sine of, let's do 23 pi over 6. Try it out. Whatever method you want to do to get it. So some people are going to convert to degrees. Some people are going to keep it here. Most people will not keep it here. Try it out. So the first thing you might want to do is convert radians to degrees, pi on bottom. Shh. So we're going to multiply by 180 over pi. 23 times 180 is divided by 6 is what? 690 degrees. So this is also the same as sine of 690 degrees, which is also the same as sine of what? 330, because I can subtract 360, correct? And what is the y at 330? Negative 1/2. Now, I can check these every single time. Remember, I can check these every single time. I can type this right into my calculator. So I go to press the sign button and I slap my hand and I say, radian. It's 23 pi over 6. Okay. So you slap your hand and you say radian mode. Everyone do it. I don't mean slap your hand and say radian mode. I mean everyone go to put it into radian mode. But you can slap your hand and say radian mode if you want. So go to your mode and make sure it's in radians and type in sine 23 pi divided by 6. And we get negative 0.5, which is negative 1/2. Do you agree? Okay. So do sines and coses make sense? Sines and coses are easy. They're the ones right on your unit circle. Now remember I gave you tan. Go to your tan, your Xbox. What I want you to do is go to your formula sheet for a second. So off of our unit circle we have coses and sines. That's the only thing we can get off of there, correct? Coses and sines. But if you go look at tan at the very top, right? It's the second formula down. What does it say? Sine theta over cos theta. Do I have sines and coses? Yep. So tan theta equals sine theta over cos theta. That's how I get tan theta off the unit circle. So it's going to be more work. Okay? So I'm going to do tan of, we'll do a few tans. Tan of 30 degrees. So what's tan of 30 equal to? Sine of 30 divided by cos of 30. Why am I writing it sideways? Because sine and cos of 30 are fractions, and you're not going to stack fractions. You always write fractions side by side. So what is sine of 30? 1/2 divided by cos of 30? Root 3 over 2. When we divide fractions, what do? Yeah. So you do the reciprocal of it and then multiply. So you invert and multiply what you're dividing by. Sometimes say flip and kiss in JP2, I've heard. Anyways, you multiply and you flip the right-hand side. Then the 2's cancel off. And I'm left with 1 over root 3, which is a lovely answer. However, the denominator is not rationalized. Yeah. We're going to have to multiply by root 3. So I get root 3 over 3. It's a lot of work, isn't it? All of the tan 30s, reference angles, will all be root 3 over 3s. Some will just be positive and some will be negative. Okay? So, how do I know which ones are positive or negative? Well, if I did tan of 150, it would equal sine of 150 divided by cos of 150. Still a 30-degree reference angle, do we agree? Sine of 150 happens to still be 1/2, but cos of 150 is negative root 3 over 2. So what are we going to actually end up with an answer as? Negative root 3 over 3. Same answer though, but it'll just be negative root 3 over 3. Do you see how the 30-degree reference angles for tan are all root 3 over 3s? Some are just positive and some are just negative. Let's look here. Tan of 210. It's going to be sine of 210 divided by cos of 210. At 210, both sine and cos are negative. So I get negative 1/2 divided by negative root 3 over 2. So what's my answer going to be? Positive root 3 over 3, because they're both negatives, right? And then tan of 330 equals sine of 330 divided by cos of 330. Which is sine is negative 1/2, cos is root 3 over 2. So what's my answer going to be? Negative root 3 over 3. Remember your teacher talking about cast rule last year? Cast rule?
Oh, yeah.
So cast rule makes the C, starting here, C-A-S-T, or you can start in this corner and use the acronym that makes absolutely no sense because none of you are in calculus. All students take calculus. Or you just do cast. Now what cast stands for is where the trig ratios are positive. So I'm literally reviewing, all of what I'm reviewing right now is all grade 11 stuff. You just don't remember it. But everything we're reviewing is grade 11. So this is cos. Cos is positive. All are positive here. This one sine is positive. This one tan is positive. Do you see that? Okay, let's see if this makes sense. I'm looking for tan of 30. 30 falls here. What are all my answers there? So is this one. Okay. Tan of 150. 150 lands here. Is tan positive here? No. Look at my answer. It's negative. Tan 210. 210 falls in here. Is tan positive here? Yes. So is my answer. And the reason why is you're going to divide two negatives. It's going to make it positive. That's why it always works out like that. That's why CAS works. And then tan of 330. 330 falls in this quadrant. Is tan positive here? No. So you should know your sign at the very least of your answer just solely based off of cast. Okay? I'm going to give you a few tan questions you're going to try. So I want you to find tan. So we know tan, we know tans of 30s are root 3s over 3s, correct? Mm-hmm. I want you to do tan of 45. And I want you to do tan of 60. Go do those two. Tan 45 is the same as sine 45 divided by cos of 45. Just so you know, I did the worst one for you. The 30s are the hardest because if you rationalize, you get root 3 over 3s, right? For all the 30s. The 45s, sine 45 is root 2 over 2 divided by cos 45, which is root 2 over 2. So my answer is just 1. All the 45s result in 1s or negative 1s for tan. So let's see why. So if I give you the 45, this 45, tan 45 is 1. What if I do this 45 though? So tan 135 is actually negative 1. And the reason why is, what do we have here? Cast, correct? Tan will always be negative if I pull an answer out of this quadrant. Tan will always be positive if I pull a quadrant out of this quadrant. If I pull it out of this one, which is 225, what's my tan going to be? Positive 1. And then out of this one, which is 315. We agree? Okay, tan of 60. Tan 60 is sine 60 divided by cos 60. Sine of 60 is root 3 over 2. Cos of 60 is a half. So I have to flip it. Root 3 over 2 times 2 over 1. The 2's cancel. I'm just left with root 3. So it's actually the nicer one because you don't have to rationalize any denominators. But let's talk about all the 60-degree references we can hit. So if I'm here with this is just 60, tan of 60 is root 3. Then this one is tan of 120. And what's it going to be? Negative root 3, because tan's not positive here, right? Go to this one. Yeah, tan 240 is going to be positive root 3 because it's all positive there. And this one, tan of 300. So you see how the actual answer doesn't change, the sign changes? Because if you actually fill your unit circle incorrectly, you'll always be dividing root 3 and over 2 divided by a half. Just one of them might be negative, both of them might be negative. Right? Okay, another thing to discuss. Remember, all of this is from last year. Just might never fresh in your head. Okay, what about the arms? So I have 0 degrees, and it's at 1, 0, correct? It says radius of 1. Then I have 90 degrees, and it's at 0, 1. Then I have 180 degrees, it's at negative 1, 0. And then I have 270, it's at 0, negative 1. Then we go back to 360, and then all the coterminals with it. We agree? Yeah? Okay, cos and sine are easy for these. Because what's cos of 0? Cos of 0 is 1. What's cos of 90? 0. What's cos of 180? Negative 1. What's cos of 270? 0. Okay. What's sine of 360? 0. What's sine at 90? 1. Sine at 180? 0. Sine at 270? Negative 1. Correct? So it's just the y's and the x's. Cos and sine are easy. If I do tan, though, say I do tan of 0 degrees. Well, it's going to be sine of 0 divided by cos of 0. Why am I writing these on top of each other, but the other ones I wrote side by side? Because they're not a fraction. Mind blown. So sine of 0 is what? 0. Cos of 0 is 1. Can I have a 0 in my numerator? Yes. Can I have a 0 in my denominator? No. So if I go 0 divided by 1, which is what this means, 0 divided by 1, how many times can 0 be divided by 1? 0 times. So that's why the answer is 0 when the 0 is in the numerator. If I do tan of 90, though, it's going to be sine of 90 divided by cos of 90, which is 1 over 0, which is actually, how many times does 1 divide by 0? Can you put, it doesn't. You can't have a 0 in the denominator. So this stands for undefined. You have to watch with the arms because they could be answers of 0. They'll be answers of 0 on the x-axis, right? Because 0 will be in the numerator. And there'll be answers of undefined in the y-axis because this one will be 1 divided by 0 and this one will be negative 1 over 0. Does that all make sense? Good, Sean. Okay. So we're good with the main trig ratios, correct? We're good with cos, sine, and tan, which was taught last year. Cosine and tan, we're good with those. There are 3 more trig ratios if you look on your formula sheet. So I'm going to write them up here. You can write them on a separate sheet of paper. It might help you out. We're writing these. I'm literally reviewing a whole bunch of stuff with you before we even get to the notes because I'm trying to get your brains wrapped around the unit circle. So we have sine theta. Sine theta equals what over what? What's the formula? Sine theta equals sine your resume. Sign your resume. Okay, then we're going to do cos. This is a nice cheat sheet to have beside you. You're going to still have to know it when you get to a test, but it'll be helpful for the next little while. Cos theta equals x over r because it's cook extra rice. So before every test, I would write these at the very top of my test because then I have them. And then tan.
Texture X.
Texture X.
It's so much better than the Xbox.
You shouldn't.
You shouldn't can your Xbox.
Well, it might need vitamin D.
You also shouldn't text your ex.
Okay.
Because you can speak to that.
We'll change it. Okay. So, these are called the 3 primary trig ratios. It's the only things you've ever learned about. Then after them comes the 3 secondary trig ratios. Secondary trig ratios. There's secant, cosecant, and tan. Now, if you forget which goes with which, you have a formula sheet in front of your face. So in front of your face, you have this. You have cosecant theta is 1 over sine. You see that? So cosecant goes with sine. 1 over sine just means it flips. So I'm going to show you what I mean. So don't write this part. I'm just explaining why this works. So if I have cosecant theta equals 1 over sine theta, I'm just showing why this works. We're going to know the reciprocals of each other after. If sine theta is 1 divided by sine theta is y over r, right? So what are we going to do? Flip it and multiply by r over y. So your answer is just r over y. So the secondary trig ratios are just reciprocals of the primary trig ratios. And the other way to remember it is tan goes with cotan because it has the same word. Sine doesn't go with secant because they both start with s's. Cos doesn't go with cosecant because they both don't start with c's. They go with opposites. So if you look on there, it shows it to you. It says sine equals 1 over cosecant. So here we would have cosecant theta equals, if it's sine your resume, this is going to be r over y. It just flips. The secondary trig ratios are reciprocals of the primary trig ratios. Cos theta here, if you look it up here, cos theta says it is, secant says 1 over cos. So secant and cos go together. So secant theta doesn't equal x over r, it equals r over x. It's just it flipped, correct? And then tan goes with cotan. Cotan theta is y over x, so it's x over y. Does that make sense to you? That it's just the reciprocals of each other. Okay, we're going to go to the notes I handed you. So right now we're not going to need the unit circle because we're not talking about the unit circle, but we will need our formula sheets to help us out. And by our formula sheets, you really will just need these 6 trig ratios that are sitting in front of your face. Okay? So with the cast rule, you talked about the cast rule last year, C-A-S-T, and we talked about cos being positive, all positive, sine positive, tan positive, correct? What we need to know is that there are 3 other trig ratios we could do now. We had 6 of them. We had 3, now we have 6. So their best friends are still going to stay positive with them. Because remember, if cos is positive, secant's going to be positive because I just take its fraction and flip it, correct? If tan is positive, cotan's going to be positive because I just take its fraction and I flip it. So if it's positive, it stays positive, right? The numbers just flip-flop. We agree? So what you need to know, and you could put this on your little sheet if it helps you out as well. Cos is positive here, well, so is secant because they're friends. Sine is positive here, so is cosecant because it's just the reciprocal of sine. Tan is positive here, so is cotan. And then all are positive in quadrant 1, all 6. So here it says in front of you, it says, given the following point on the terminal arm, you have to spot these. These questions will come up. It says, given the following point. If it's a point, what should we do? Label it x and y. It's coordinate. Let's label it. It's on the terminal arm of some rotational angle. Does it say it's on the unit circle? If it was on the unit circle, my radius would be 1, correct? But it doesn't say it's on the unit circle, so we can't assume that. Find the exact value for all 6 trig ratios and the rotational angle. We'll do the rotational angle later. We're just going to do finding the 6 trig ratios for today. Okay? So, in order to do the 6 trig ratios, I need x, I need y, and I need r. Do I not? Because I don't have r, do I? But I do need it because it's y over r, x over r over x, y over x, right? Like I need my r's too. So what we do is we actually have a coordinate. So I'm going to draw it here first. Let's sketch it over here. We have -2 and -6. And it lies on a terminal arm. So this would be my initial. This would be my terminal. So I know the actual standard position angle is between 180 and 270, correct? At the very least, I know that this standard position angle lands between 180 and 270. Now, make sure you guys are paying attention, not on your phones. So what we can do is we actually have a triangle sitting in here if you don't see it. With the x-axis, there's a triangle there. This is -2 for my x. And this is -6 for my y. It's labeled there. So how do you think I can get my r, my radius? Pythagorean theorem, because this is a 90-degree triangle. Okay? So Pythagorean theorem, this is my hypotenuse. So it's c squared equals a squared plus b squared. We're going to say r squared equals x squared plus y squared. So the first thing I have to do is find that r. So I'm going to get, and don't write huge because you're going to have to fit it in here. R squared equals -2 squared plus -6 squared, which is 4 plus 36, which is 40. Then we have to square root. When we take the square root, we need what? Whenever we take the square root of anything. Plus or minus. R is the radius. Can a radius ever be negative? No, it's a standard of measurement. So we have r equals root 40. Going back to grade 10, we have to reduce that. You can never leave it as root 40, you will lose marks. It's 2 root 10. Because root 40, we have to figure out what perfect square it breaks into. It breaks into 4 and 10. And when you take the square root of 4 out, it becomes a 2. So I'm left with 2 root 10. So now I have everything I need. I have x equals negative 2. I have y equals negative 6. And I have r. So I can do all my 6 trig ratios. So let's start with sine first. Sine your resume, right? If it's sine your resume, it's going to be what over what?
-6 over the hypotenuse.
Yeah, negative 6 over 2 root 10 over the radius. Now, if we can reduce, we do. We can take a 2 out of both. So we're going to get negative 3 root 10. Am I done? No, I need to rationalize my denominator every single time. That's why you're taught this in grade 11. Multiply by root 10, multiply by root 10, and so I get negative 3 root 10 all over root 10 times root 10, which is 10. Done. So I've done 1 trig ratio. I have 5 more to go. Cos theta, good thing on a test is they'll just give you a coordinate and then ask for usually 1 trig ratio, like cos, sine, tan, cotan, right? So cos theta, cook extra rice. So we're going to get negative 2 over 2 root 10. The 2's can cancel, so I'm left with negative 1 over root 10. And then I need to rationalize my denominator. So I get negative root 10 over 10. So we did sine, we did cos, now we can do tan. We actually did the hardest ones first. Tan is your x box, or text your x, I guess. And it's going to be what over what? Negative 6 over negative 2, which is 3. Wait a second. My sine is negative, my cos is negative, and my tan is positive. How's that possible? Cast, I drew it. Did I not draw it? It's in this quadrant. What's the only thing that's going to be positive here? Tan and cotan. Right? So it's tan your x box. Then we have to do the other ones. So cosecant is sine flipped. Cosecant and sine go together, secant and cos go together. S's aren't with S's, C's aren't with C's. So if it's sine your resume, cosecant is resume your. It's r over y. They flip. So we're going to get r, which is 2 root 10, over y, which is negative 6. Take a 2 out, and I'm left with root 10 over negative 3. Done. Secant goes with cos. So if it's cook extra rice, this is going to be rice extra. So we're going to get 2 root 10 over x, which is negative 2. Now you could leave this as root 10 over negative 1, but they won't give that as an answer. Root 10 divided by negative 1 is what? Negative root 10. And then cotan is text your x, so it'll be x your. So x your. All right, 1/3. Then you're going to flip over. Okay, I want you to do 3 and negative 4. And then down here, I'm changing this one. I want this one to be nope. So try this one out, and then I'll write the other point down. So number 2, we're doing 3 and negative 4, and then number 3, we're doing negative 4 and 8. I forgot to press that. We'll do it for this one. Okay, so here we have x, y, r squared equals 8 squared minus negative plus negative 4 squared. R squared equals 64 plus 16. R squared equals 80 square root. And I get R equals, is that 16 and 5? So I'm going to get 4 root 5. And then I need to do sine your, so 8, resume 4 root 5. The 8 and the 4, I can take the 4 out, so I'm left with 2 root 5. And then I need to rationalize it. So I get 2 root 5 over 5. Then cos theta is cook extra rice. So I'm going to get negative 4 over 4 root 5. The 4's cancel. I'm left with negative 1 over root 5. And then rationalize it. Then tan your x box, 8 over negative 4, which is negative 2. And then cosecant, instead of your resume, it's resume your. So it's 4 root 5 over 8. Take 4 out of each, so I get root 5 over 2. Secant is rice extra. So 4 root 5 over negative 4, which is just negative root 5. This one? This one?
Yeah.
Not the one. No. And then cotan theta. So it's tan your x box or text your x. So this is x your. So I get negative 1/2. Okay? So the homework I'm going to give you is these 3 things. If it says, where it says, and give me the rotational angle, I don't want the rotational angles of them. I just want the 6 trig ratios. And I'm going to make you do some of like the cos of 30 and those ones where you actually have to figure out off your unit circle like we were practicing before. So make you practice those as well. So this one here for number 5, it says for each point sketch 2 coterminal angles in standard position. I don't want any of that. We're going to do that tomorrow. For number 5, I just want you to use the coordinates they gave you and get the 6 trig ratios. Okay? So I know if you ask me, what the heck is this, in about 5 minutes, I'm going to be like, guys, we just went over it. So, page 202, number 5, BCD. I want 6 trig ratios. I know it doesn't say that, but that's what I want. Okay? And then, number 1, we're going backwards because I want you to practice these ones first. Number 1, it says, what is the exact value? If it says, what's the exact value for the trig ratio, it's asking for your answer off your unit circle. Exact value means don't type into your calculator and give me a decimal. Just go to your unit circle and give me an answer. So I want you to do 1A, B, C, G, J, K, J, K. That's it for now. You have 20 minutes. If you actually work, this should easily be finished before you leave this classroom.
20 minutes.
These are coming right off the insert.